Morning everyone, myself Navyatha Ravi, working as Assistant Professor in Cybersecurity and Data Science in MLR Institute of Technology. Today I am going to deal with the topic Logical Database Design. The overview of this topic includes entity sets to tables, relationship sets to tables without constraints, translating relationship sets with key constraints, translating relationship sets with participation constraints, translating weak entities, translating class hierarchies and translating ER diagrams with aggregation. So these are the topics included in logical database design. The next concept is translating relationship sets with participation constraints. So what is, just in the previous slide we have already discussed what is total participation, what is partial participation. So here partial participation is nothing but what? Not all the entities in the employees will participate in a relation. Only some entities will participate in a particular relation. That is what we call as partial participation. So let us create a table for this one. Create table managers, which consists of attributes number, that is nothing but employee number. Next, department name. Next, here let us consider the attribute since, which is nothing but descriptive attribute, which is called as descriptive attribute. So the attributes which are defined for a particular relationships, those attributes are called as descriptive attributes. And here let us consider the primary key for this relationship. The primary key is nothing but number, that is nothing but employee number. And what is the foreign key? That is also a number which references employees table. And here one more thing I have mentioned. What is that one? On delete no action. On delete no action. That means here foreign key is nothing but a key which acts as a primary key in another table. That means to relate two or more entities, two or more tables, we use foreign key concept. So, if at all, SID, S number, SID, department ID. Let us consider these two tables. This is the primary table and this is the dependent table. Dependent table. This is the parent table. Parent table or primary table, this is the dependent table. Right. So, SID, S number. SID means S name 1, 2. Here S name X and Y. So, what is here? S1, 2 and department CS, DS. To relate these two, we use the concept of foreign key. So, in this table, what is the primary key? SID. So, in this table, what will be the foreign key? SID will be the foreign key. Why? Because this column will act as primary key in another table. By using this column only, we can able to retrieve these kind of data. We can able to retrieve only these department IDs. That is the representation of foreign key. So, what is the meaning of this one? On delete no action. If at all one table is dependent on the another table, one table is dependent on another table, then we want to delete, for example, this ID 1. We want to delete, if the situation comes to delete student ID 1. If at all directly I can able to delete this one? No. Why? Because based upon this parent table, a child table exists. That is why I may not delete this ID. Why? Because depending on this particular row, in another table, the row exists. The child row exists. That is why here, what is the meaning of this one? If at all you want to delete this one in the primary table, no action will be taken. That is the meaning of on delete no action. If at all you want to delete, you have to priorly delete in the child table and you have to delete that row in the parent table. Next, translating weak entity sets. As I already told you, what is strong entity and weak entity? Strong entity is nothing but an entity set that contains a primary key attribute. That is what we call as strong entity. What is weak entity? An entity set that doesn't contain primary key and it depends upon some other entity to retrieve uniquely. then it is called as weak entity, and it is represented by double rectangle, and the relationship between the primary and the relationship between the strong entity and weak entity is nothing but what we call as identifying relationship, which is represented by double diamond or double rhombus. So, let us consider this example, which consists of customer and loan. Here customer is the strong entity, loan is the weak entity as represented in the diagram. So, to relate these two, we use what kind of relationship? That is nothing but identifying relationship. The relationship between strong entity and weak entity is called as identifying relationship. So, here CID, this will be considered as primary key. Why? Because it will be unique. That's why it is considered as strong entity. And here the we can loan name and loan date. Loan name, we can have the same loan names which can be taken by different types of customers on the same date also. So, we cannot retrieve the data uniquely. That's why it can be considered as weak entity. So, for this kind of entity sets or else relationship, how we can able to convert it into a table format. Let us discuss this one. Here I am representing, I am creating a table for borrows, that is nothing but a relation for borrows, which consists of attributes. So, if at all I used to create a relation, that is nothing but I used to create a table representation for a relationship, then I have to consider the attributes from both the entities which are related to that relationship. So, here CID, that is nothing but an attribute which related to the first entity. What is loan name? An attribute that is related to the second entity. Why? Because here I am creating a table with a relationship, right? Next, what will be the primary key here? That is nothing but CID and L name. Why? Because here L name can't be uniquely derived. Why? Because we can have same loan names will be taken by different number of customers on the same dates. We can't uniquely identify those data. If at all we used to combine these two, then we can able to uniquely identify. Let us deal with this one with simple example. Let us consider student ID and student name. Student ID and student name. So, here student ID 1, 2 and student name A, right. So, if at all I used to consider with SID, then I can uniquely identify particular student 1, roll number 1 and roll number 2. If at all I depend upon only name, by seeing this name, a student can have the same names, right? Student can have or a person can have same names. Then how I can uniquely identify those things? So, with the help of SID only, I can uniquely identify this particular student. That means, if with the help of roll number and name, if I used to combine these two, then only I can identify that particular student. That is the concept included here. So, here primary key can be a combination of CID with the L name, so that I can uniquely retrieve the data. Next, what will be the foreign key? Foreign key is nothing but the CID, which acts as a primary key in customer table. On delete cascade. On delete cascade, here one more thing I have included. What is this meant for? On delete cascade. That means, so if at all I used to mention this one, if I have deleted some rows, I want to delete some rows in primary table, then automatically those rows will be deleted in the dependent table also. In the dependent table automatically by representing on delete cascade. If at all I used to delete some rows, particular rows from the primary table, then priorly I should mention here on delete cascade. So, what it will do by seeing this instruction? So, if at all I used to delete a data from a primary table, then those data which is represented in the child label will be automatically deleted. So, that's about translating weak entity sets. Next, translating class hierarchies. So, as we have already discussed, nothing but what is a hierarchy? Here we have discussed about two approaches, top-down approach, bottom-up approach. So, what is top-down, bottom-up, specialization, generalization, these concepts we have already dealt. So, here we have considered three entities here, person, student and teacher, three entities. And a person can be a person, this is what we call as relationship. in hierarchies, in the concept of hierarchies, relationship is nothing but is a relationship we will use. We will use is a relationship, which is represented by down triangle, right? So here inverted triangle or else. So person can be a student or can be a teacher. So what are the attributes for this person? Name, age and gender. For each and every person, we will have common attributes. We will have name, we will have age and we will have gender also. And a person can be a student and a teacher. So here what are the attributes of the student can be roll number, and what are the attributes of the teacher can be employee ID. These are the only attributes for the student. No, right? So priorly a student is a person. So we can inherit the properties of these entity for particular this subclass entity. That means here I used to deliver that this can be a parent class or parent entity, and these two are nothing but subclasses. Here comes the concept of inheritance. So what is inheritance? Inheritance means child class can inherit the properties of parent classes, right? So here person is nothing but can be treated as a parent class. And what is here? Student. Student is nothing but a child class, can be considered as a child class, which can be inherits the properties of the parent class. That means a student can inherit the properties what? The name, age and gender. Name, age and gender. These three are the properties of parent class only, right? The common properties. And what is the teacher here? This is also another entity which can inherit the properties of name, age and gender. Name, age and along with these properties, this child class can have unique properties also. So there is no rule how the parents behaves like the child, right? No, not right. The child can have their unique properties unlike parents, right? That is the thing. So but they can inherit the properties by seeing their parents. They can inherit the properties. That is the thing here. So what I used to deliver here is we can convert this ER diagram into tabular representation by creating all the three tables. That is the first option. And what we can consider second option also. What is that one? By considering only these two, we can consider we can create a tables by considering only these two, that is nothing but student and teacher, by inheriting the properties of the parent class. No need to construct extra table or no need to create extra table, person table for this one. We have two options, that is we can consider tables, we can create tables for three entities, person, student and teacher. And the second option is we can create only two tables, student, teacher. Why? Because the student teacher can have the same properties as person, right? So that is what the thing, translating these class hierarchies into tables. And the last one is translating ER diagrams with aggregation. So what is aggregation? What is aggregation here? Aggregation is nothing but a set of entities can be combined together. Set of entities can be combined together, or two relationships can be related with each other. That is only possible with aggregation. So here, what is the meaning of this one? Teacher guides student who works on project, or else student works on project guided by the teacher. This is what the aggregation. And the set of entities, group of entities can be considered as a single entity which will be related to another entity. That is what we called as aggregation. And the second more thing is two relationships can be directly related with each other only through aggregation. That is what the second point. So in this case also, by considering this aggregation diagram, we can convert this in the form of tables by considering or by creating three tables. We can create three tables for student, for project and for teacher. So for student, what will be the attributes? SID, SName. For project, project ID, project name. What will be the teacher? Employee ID, employee name. These are different kinds of attributes that we used to consider, and apart from these three entities, we can create the tables for relationships also. We can create the tables for relationships also. So total from this diagram, we can create total 5 tables, and we can relate each other. Meanwhile, we can lesser those creation of tables by 3 or 2. Why? Because here by considering this relationship, guided by relationship, this includes the concept of student and project. This relation is related with this particular entity. So we can delete this works on table. That means we can ignore of creating this works on table. Why? Because this guided by relationship, this actually contains the data of student and project. So obviously, why unnecessarily creating the works on relationship table? It's a waste of space, right? So here in this way, we can reduce the creating tables by considering our relationships also. So in this manner, we used to deal with logical database design. The summary of this today's concept is nothing but converting ER diagrams into or translating ER diagrams into a set of tables. So here we can able to transfer we can able to translate entities into tables or relationships into tables. That is the thing. Thank you.